So let's summarize and take some notes on what we call rose curves. They're called rose curves because each of those loops that you have been drawing remind us of petals. So let's summarize what we did. A rose curve is a graph that is produced from a polar equation in the form r equals a cosine n theta, or r equals a sine n theta. A can't be 0, and then n is an integer greater than 1, greater than or equal to 1. If there's only 1, it's not really a rose curve because it is a singular loop, but it's sometimes in that category. So to determine the number of petals, if n is odd, there are going to be n petals. If n is even, there are going to be 2n petals. And you should have seen those observations as you graphed all of those curves. And we're going to look at what it's like to sketch some of the curves by hand without a calculator. So some general characteristics about our graph. The domain of rose curves is all real numbers. Your range is going to be bounded because the rose graph is bounded and continuous. And it's going to be bounded based on the value of A. So your range is going to be from negative absolute value of A to positive. So for example, if I have R equals 5 cosine 2 theta, my range would be negative 5 to 5. If my equation was R equals negative 3 sine 2 theta, my range would be negative 3 to 3. Rose curves are symmetric, and their type of symmetry depends on a few things. The first thing that it depends on is the n value, the number in front of theta, or a frequency that we're used to calling it when we're graphing our regular trig curves. So if n is even, you are going to have symmetry over the origin, the x-axis, and the y-axis. And then just something to note, sometimes your x-axis is called your polar axis, and your y-axis is sometimes referred to the line theta equals pi over 2. So depending on the textbook or the worksheet, they may have those phrasings as well. So that's the first distinction. If it's even, it has all 3 types of symmetry. If it's odd, it is only going to have 1 type of symmetry, and that symmetry is going to depend on sine or cosine. So cosine is related to x. So when n is odd and it's a cosine graph, it's going to have x-axis or polar axis symmetry. When n is odd and it's equal to a sine graph, it's going to have y-axis symmetry. So let's take a look at some examples and see how we use this to sketch curves by hand. So our first is r equals 3 sine 3 theta. So things to note. The first thing is that the length of my petals is going to be 3 because that's my A value. Then my n is 3, which is odd, so there are going to be 3 petals. It's odd, and it is a sine graph, so it is going to have y-axis symmetry. So you could use your calculator, but if this was on a non-calculator portion, you need to be able to graph by hand. So the first thing I'm going to determine, it's going to have y-axis symmetry, but it could look like this, or, well, and then it would be like this and like this, or it could be reversed. It could look like this, and like this. So I need to figure out, does that first piece go to the top or to the bottom part of the y-axis? And the way we're going to do that is we're going to substitute in a value. So the value at the top is going to be pi over 2. If I plug in pi over 2 for theta and I get a positive 3, it's going to be positive on the top part of my axes. If it's -3, it's going to go down. So let's do that now. I have r equals 3 sine 3 theta. And I'm going to substitute pi over 2. So this becomes 3 sine of 3 pi over 2. So from your unit circle or from your graph, you should know that the sine of 3 pi over 2 is -1. So this is 3 times -1, so r is equal to -3. So the point -3 pi over 2 has to be on my graph, which means it is going to go down. And remember, my length of my petals is 3 because of this 3 here. I also have 3 petals. I have to have y-axis symmetry. So it has to look like this and like that. Remember, this is just a sketch. It doesn't need to be perfect. And then if you want, you could go to your calculator. Y equals 3 sine 3 theta. And it matches. So we're good. Okay, let's go to example 2. So this is r equals 2 cosine 5 theta. So my length of my petals is going to be 2. I have a 5 here, which is odd. So it's going to have 5 petals. And this is a cosine curve, so it's going to have x-axis symmetry. So we need to figure out where that's going to be. So I'm going to start by plugging in theta equals 0. So for theta equals 0, I'm going to have r equals 2 cosine 5 times 0. So r equals 2 cosine 0. Whoops, not a theta. So you should know from your unit circle or from your graph that cosine 0 is equal to 1. So 2 times 1 gives me 2, which means my first petal is here on the positive x-axis. So now I have to have 5 petals total. I already have 1, which means I need 4 other ones. And remember that it has to have symmetry over the x-axis. So it's harder sometimes when they get to have bigger amounts of petals to like sketch, but it's going to look something like that. So let's move on